going through the proofs what we already know in our mathematics, rather than trying to remember all these formulas. However, there are a couple of formulas in there that would be beneficial for you to remember, and they're nice and simple ones. Okay, so for the vocal chord, PQ equals -1. That's a very handy one to remember. Okay, and probably the gradient of the tangent at P and Q. Okay, so the gradient tangent at P is going to be P, little p, and the gradient tangent at Q is going to be little q. Okay, so that's already in number 3. Okay, so the tangent to parabola has gradient P. Right, just say little things that's going to help you to remember and help you through the whole topic itself. So we've done the first 4, we've done the chord, PQ, found the gradient in the equation. We found what happens when we have a vocal chord, so we've got that property PQ equals -1. We also looked at the equation of the tangent, it's given in that form there, we already know how to work that through. And the last thing we did was the intersection of the two tangents. Down there you have the intersection point. A outside of P plus Q and APQ for those two values. Okay. With any questions or thoughts about last lesson before I continue on? 7th. Right, so that's number 5. Okay, so now we want to consider the gradient and equation of the normal to the parabola s squared equals 4ay at the point P. Right, so we had previously found the gradient of the tangent at the point P. Okay, so we found that. So now we're going to get the equation of the of the normal through P. So what's the condition for a normal to exist? Yep. Yep, okay, so in other words, it makes right angles with the tangent with that property, yep. Okay, so we need to find the gradient in the equation of that normal, okay? So we'll start from the top just to help us remember last lesson. So the equation of the parabola is there. Okay, so we need to find the gradient of the tangent by differentiating. Okay, so before we differentiate, what do I need to do? Y the subject, good. So y is x squared on 4a. Now we've got y the subject. We can differentiate. What's the first line going to look like?
Diagnosis is 2 different things.
Yes, but this is a constant, isn't it? 4 times the focal length. That's just going to be a constant number, isn't it? Yep, so
2x.
Just 2x?
Yep.
If you had y is 3x squared, what's the derivative?
6x.
Yep. Right, so what are you missing here?
With 4a's underneath.
Yes, because when you have y equals, let's say, a quarter x squared, which is essentially what this is, okay, when you differentiate, it's going to be a quarter times 2x, isn't it? Okay, so that's the principle you need to do here. 2x over 4a. Okay, so the constant is just in a fraction form, so we can simplify this. It equals x on 2a. Okay, so we found the first derivative. What's next? We're finding the equation of the normal. Okay, so what's the next thing I need to do?
Substitute that into the n1 and 2.
That x equals 2ap. So that's we need to find the gradient of the tangent first by substituting the x value. Your y dash is going to be 2AP over 2A, which is just going to be P, isn't it? Alright, so that's the equation of the tangent. So the gradient, sorry, that's the gradient of the tangent. So remember at P, just got the lowercase parameter representing the gradient of your tangent. Okay, that's just a handy one to remember. Okay, you could go straight home and write that if you want, if you remember those little things. Okay, otherwise you need to go through the process to work it out, which we already covered in mathematics. Okay, so now we need the perpendicular gradient. Okay, so the perpendicular is what? Okay, so we flip it and the minus sign. Alright, so now we've got the gradient, and now we have a point. Alright, so we can find the equation of that line there. Okay, so y, take away y1, and alright, so substitute those three variables in and tidy it up. Okay, so again, for some reason, parametrics are just weird in their notations and what the textbook has. Okay, but of course we can manipulate that to get it into our y equals mx plus b form, or ax plus by plus c equals 0. Okay, so this whole value here is going to be c. This whole value, and when you have your form ax plus by plus c equals 0, that whole value there is going to be c, because there's no x's or y's with it. Okay. But that's what's in your notes, okay? So, okay, so that gives you the equation of the normal to the parabola at the point P. Okay, so we're not going to remember that necessarily. We're just going to go through the process, what we learned in mathematics. Get there, okay? Right, number 6. So consider the equation of the normal to the parabola h squared equals 4ay at the point P and Q. Right, so now we're going to find the intersection point of those two normals. Okay, you looked at the end result yet? That one's going to be a bit hairy. So we've got that tangent there that we've already calculated from last lesson. And now we need that normal. Right, so we need to find that intersection point. So how am I going to find the intersection point of two lines? Yep, simultaneous equations. So, similarly, so we've got the equation for the tangent at P. Okay, so what's going to be the equation of the tangent at, the normal at Q? What's the equation going to be?
Everything but its q's instead of q's.
Good. Okay, so x plus q, y, 2aq plus a q, that's right. Now I did it one way and it just looked really messy, and I did it the second way and it was much better. So let me just confirm what the second method was. Save us a bit of time. so we're going to do, so x plus py equals 2ap plus ap cubed, and we've got x plus q y 2aq plus aq cubed. Alright, so let's just call it equation 1, equation 2 for today's lesson. And we're going to do a difference. Okay, so we'll eliminate the x variable by the elimination method to find the variable y. Oops, I'm going to tidy out as much as we can. Right, go up to there. So what can I do from there? Well, where have we seen this before?
Sorry?
Where have we seen this before? Not in this topic. Okay.
Difference of two squares.
Cubes. Different two cubes. 2a outside of p, take away q. Alright, so we're going to use our SOAP to expand that. Alright, so it'll be SOAP, so same sign, so p take away q. So we're factorising that. Alright, and it's p squared, first term squared, O for opposite sign, so it'll be plus. Multiply the two product together, multiply the two terms together, and then the last sign is always plus.
Would that be 2 different?
It's just PQ. Yeah, it's a slightly quadratic, but not quite because there's no 2 there. Okay. So now we have A and, so we're looking at this term here, and that term there, 2 terms there. So we've got A and P take away Q as common factors of those 2 terms. Alright. So A, P take away Q. Alright, so we're left in this first set of square brackets with the 2 left, plus, and what we've got left is everything in that set of brackets there, part of the second term. Right, and we need y by itself now. Right, so we're going to divide by p, take away q, and that'll cancel that factor out. Okay, so that's why we're factorising there. So we'll get it back into the format. So y is going to be a, just writing it like your notes, we've got p squared plus PQ plus Q squared plus 2. Okay, so that's the y value where these two lines intersect here. So it's a nice complex, something more complicated formula. So of course, I'm not necessarily going to remember that, okay, but we can work through it. Alright, so that's now equation 3. And let's put it back into equation 1 to get the value for x. Or you can put it in 2, you'll get the same answer, okay, but I typically like working with P better than Q's. I don't know why, probably because it's first in the alphabet. So x plus PA, P squared plus PQ Right, so we need the value for x, so we just about got it. We're going to move this over to the other side, okay? But what else can we do here? We can expand, okay? Because we've got PA times P squared, which is AP to the power of 3.
Yeah. Oh, yeah.
Okay, so we can simplify from that. So x is going to be 2AP plus AP cubed. Okay, so everything's positive on this side, so when I move to the other side, everything's just going to become negative. Minus AP cubed plus AP cubed, take away, sorry. Take away AP q squared, take away 2AP. Lots of things cancel, don't they? So it's going to be negative APQ, common factor of those two terms, and then we're left with a P cross Q. Right, so the next point we need to remember is I've told you already that PQ is minus 1 if the chord PQ is the focal chord. Okay, so if this, if P and Q line up with the focal chord and we're finding the intersection of the normal, alright, all we need to do is substitute in minus 1 for PQ. So the x value is going to be A outside of P plus Q. And the y value is going to be A outside of P squared plus Q squared plus 1. Yep, okay, so that's what I'm saying. When you're recognising PQ and you know things are focal chords, this only works as focal chord, okay, and got that information, that's something that you'll need to use in order to work further through the questions and what we're doing right now. Okay, so I'm just putting these things in your mind now, so when we work through questions, you'll hopefully be a bit more aware of what's going on. So any questions there? So we found a whole series of things in there. So we've done number 5 and number 6 now. So we found equations of chords, found equations of tangents, equations of normal, and we've also got the intersection of tangents and the intersections of normal in reference to our parameters. Okay, Now don't forget, if you're sketching and you're given parameters, okay, typically that's a good way to orientate them, alright? Close enough that you could put a focal chord in there, sort of principle, because the way when you do tangents and normals, it just looks nicer. Okay, if you put P and Q there and you're trying to find an equation of two tangent or two normals, it's just too much to close. So a nice sort of that sort of distance, and that helps me be more aware of what's going on. Okay, so that's my suggestion on how you work through the question. Okay, so by doing similar proofs to above, the equations of the tangent, normal and chord can also be derived from point in Cartesian form rather than parametric forms. Okay, so all that's saying is if I give you the Cartesian form of these points, okay, we go through the same process, what we've just gone through, to get the values of everything there. Okay, so let's do the parabola. We've got the point A at x1 and y1, just two numbers. Okay, let's find the equation of the tangent at A using those values. Alright, so we already know y dash is x on 2A. Now remember, I've told you that these all work with the parabola x squared equals 4ay. Okay, I haven't seen any question that suggests another orientation. And looking through this, you don't really want to have another orientation, okay, because that would just make things, obviously we can still work through the maths and get all these similar things that we need, but I haven't seen anything other than that orientation, okay, so hopefully we should not expect anything nasty. It's already nasty enough in terms of all the work you need to do, okay, for them to throw a different orientation, it's just going to be too much, I think, but that's all I know about it. Alright, so at x equals x1, okay, so it's going to be some number, y dash is going to be x1 over 2a. Okay, y take away y1 is m, x take away x1. Alright, we've already got substitution in for x1, y1 as the point x1, y1, okay, just need to put the gradient in there. So 2a, y take away 2a, y1 is equal to x, x1, take away x1 squared. So putting that fraction there, bringing it up, expanding through. Right, so on x, we've got, yep, so x1 the subject. So just moving that, just swapping the sides. So we have 2a y, take away 2a y1 plus x1 squared. Okay, now that's not finished. Alright. Any suggestions you can make, what we can do from there to simplify it even more? Well, what is going to be the value of x1 squared? No, in terms of something else that's on the board. What's the equation of the parabola? So, x1 squared is going to equal what? Y1. Yep, so just substituting in 2 points there. Okay, because this is a point, isn't it? It's just a value of the x coordinate of here. So we substitute that into formula and get the y equivalent value. So 2ay, take away 2ay1 plus x squared, so plus 4ay1. Okay, and this now allows me to add like terms, the last two terms there. And now also allows me to factorise. Alright, so again, you're not necessarily going to remember that formula, but we're just going through how to derive them, okay? Alright, so that's the equation of the tangent at A, equation of the normal at A. Okay, so the perpendicular gradient to the tangent is what? The perpendicular gradient. Okay. Yep. Negative what? Sorry? I didn't actually hear you. So what did you say?
It's going to be -1, or negative that.
And the reciprocal, remember?
Yeah.
Okay, to find the perpendicular gradient, we've got to flip the reciprocal with the opposite sign. Okay? We're going to negative 2a over x1. Y take away y1, you can be negative 2a on x1, outside of x take away x1. How have they got it? Way over. Yep, that's all they've got there, yep. Okay, but again, we can manipulate that, we can expand that, put it whatever format we want, we need for the question, whatever. That's what's got in the textbook. Right, question. So, the next property, so the last block above the heading 11.12, the equation of the chord of contact xy of tangent drawn from an external point to the parabola is given by that equation there. Okay, so let's draw it. Right. So we pick an external point. I'll put it about here. Okay, that's going to be your external point x1, y1. Alright, draw the tangent from that external point to the 2 points where it will touch the parabola. Something like that. One's vertical. Oh, could be vertical, so. Okay, the 2 points there, join them up for the chord. Okay. So right, so we've got the external point, two tangents to touch the parabola, okay, the chord that connects them, we're about to find the equation of that chord. Okay? So okay, so from the first property, that were covered in the notes. Okay, so we've found the equation of the chord PQ. Okay, now the letters we are given is X, capital X and capital Y. That's what we're finding, the equation of the chord of contact XY. So equation so it is Y, take away a half, P plus Q, that side of X, plus APQ, which is 0. So this is really 2AP, AP squared, and this is 2AQ. Okay, just picking your 2 points there. Yes, there probably should be P's and Q's, but in your note there are X's and Y's, but we can use that principle there. Okay, and we also have derived the intersection of your 2 tangents, and from 4. Okay, so property number 4. So tangent tangents intersect at A, P plus Q, right, so that's that point there. Okay, so that means my x1 is going to be A outside of P plus Q, and my y1 is going to be APQ. Alright, so we are going to right, so here's our equation of chord. Okay, we've got x1 and y1 represented by the parameters. So what we're now going to do is eliminate these 2 parameters here. Okay, we're going to eliminate p's and q's. Right, so we need to rearrange one of the equations. So we already have APQ, y, 1, okay, and for p plus q, I'm going to replace it with an x1 over a. And replace them in 2, and I'm going to eliminate the parameters, okay. So, x1 over a is p plus q. What equation, what number are we up to for labelled the equation today's lesson? You know how we've been numbering thing today?
Yeah.
Do you substitute in other equation? What number are we up to?
Oh, we started again, so like 3.
3. The last, we're up to 3. Alright, so number 3. Number 4 and number 5. Okay, so number 4 and number 5 into number 3. So, y take away a half, so p plus q, replacing with x1 over a. And we have it on it, so outside of x, plus APQ, which is y1. Equals 0. maths of your maths. Okay. So if you know the values of the coordinate here, so if it's 3, 5 for example, and you ask for the chord of contact that's made with the tangents from that external point, all you have to do is substitute those two numbers I just said into that formula, and that'll give you the equation of the chord. Okay, but you're not necessarily going to remember it. Okay, you're going to have to work through it. Okay. So a question of this nature, because you've got to recall the equation of the chord first, and the intersection of the tangent, and then go through and substitute all of them. This is going to be a big question. If you had to derive everything, derive this, like I've done it, and then derive that, and then use that. Okay, so I wouldn't expect this question. Maybe one of the last questions of exercises, this sort of question might pop up. Okay, but certainly not an assessment. It's just going to take far too long to go through and actually derive everything out of that. Question? Probably a good natural stopping point, so we'll stop there. And we'll look at a couple more properties and start working through some questions and incorporating everything we've just done the last couple of lessons.
Hopefully the stop makes sense.
Well, it will. Once I'm showing you this, that what we do question-wise will make more sense what we're going through. Yep. Okay.